Our next circuit that we're going to build is going to be our microbit circuit that's going to control the lights that is going to allow our plants to grow. And what we're going to need for this activity is we're going to need two 4-pin wires. One of the 4-pin wires is going to be useful for our screen. Another one of the 4-pin wires will be used for our relay to be able to connect to our grow shield. The other component that we have in this circuit is this really long gray wire. This is a water temperature, so it's waterproof, but we're going to use it to keep track of either our water temperature if we're doing hydroponics or our temperature of our transparent soil. If you're going to be doing regular soil, there's a soil moisture sensor that we can utilize, which is in a different video. So first thing up is let's just start connecting up our sensors. So I'm going to connect up our screen, and the screen always gets connected to our I2C in our grow shield. Then our next sensor we're going to connect is our temperature sensor, and throughout the smart greenhouse all the variables related to temperature and humidity are always going to get plugged into pin P0, which is the next pin. Now our relay, it's going to get plugged into pin P1, and that's also true across all of the grow shields and microbit circuits that are on our smart greenhouse. So now I've got my 3 sensors connected, and note you have a free pin over here, pin 2. That means that it's something that you can attach anything else that you might want to, an LED light strip to give you a warning, if the temperature of your water gets too high, maybe turn the LED strip red. You can attach an LED light. You also can attach a water sensor to be able to let it know that you need to add water to your system. So there's a number of options. So there's a number of various things that you can add to that. Next up is let's add in our power to our relay. So I'm going to flip my grow shield around, and red always is going to go to the 3.3 volts because that's the positive side of our shield, and then black, which is always negative, is going to go to the GND side or ground. Okay. So now that's going to be connected, and you can give them a little tug, make sure that they are firmly attached, because that's how we're going to get our power. So now I've got all my circuits connected, and the nice thing about these barrel plug connectors is I've got my female for my relay, I've got my male one attached to my LED lights, and all I have to do is plug them in. Last thing, I need to just make sure that I plug in my bit, and I've already got the program transferred to my microbit. And when you're, again, plugging in your power into your microbit circuit, don't plug it into your microbit if you're going to run the program. You have it plugged into the microbit again when you're downloading the program from your computer, but when you want to run it and power things, plug it into the shield, because the microbit doesn't allow enough current through, and if you send too much current through your microbit, it could damage the microbit. So now I should have data showing up on my screen. It says that it's about 73 degrees in here, because this won't only just do water, it will also do air as well. And now I've got my LED lights that are on, right? And these are bright lights, okay? And we're going to learn how we attach those to the greenhouse. Now, notice that now my light is low on, and so my little lights are on. I can actually have them come on and off by shining them on the microbit. Because how this works is on the microbit, when light shines on the LED display that is on the bit itself, it generates a voltage, and it detects that voltage. And what we did is we wrote a function that calibrated that voltage reading to a lux value, and lux value is the amount of light. And so when my light levels get high on my microbit, my LED light's going to turn off. And then when I have my LED lights out of the way, the lux level drops. When they get below a certain level, they're going to come on. And that is what you're going to program into your variable set, is at what light level do you want these LED lights to come on. So there is our LED circuit.